A big hello and welcome to Guru Sehwag chemistry classes. Students, today our topic is pseudo-unimolecular reaction. This reaction it is also an important reaction of chapter chemical kinetics. Now we will discuss what are pseudo-unimolecular reactions. Pseudo-unimolecular reaction. Pseudo, this word pseudo, it stands for false. So these reactions, they are not truly of first order, but becomes reaction of first order under certain conditions. And what are these certain conditions? One of the important condition is that when one of the reactant is present in large excess. So what are pseudo-unimolecular reactions? The reactions which are not truly of first order but becomes reaction of first order under certain conditions when one of the reactant is present in large excess. There are two examples given in your NCERT book. First example is hydrolysis of esters, and another example in NCERT book is inversion of cane sugar. Let us discuss hydrolysis of esters first. Now this is ester CH3COOC2H5. This is ethyl acetate. Its hydrolysis, it takes place in presence of acid, sulfuric acid. Its hydrolysis takes place in acidic medium. Now esters on hydrolysis, they give acids and alcohol. This is acid and this is alcohol, ethanoic acid and ethyl alcohol. When time t is 0, that is initial concentration. Suppose initial concentration of this ester is 0.0 mole and initial concentration of water it is 10.0 mole. This is hypothetical value given in your NCERT, 10 mole. Now reaction has not started yet, so concentration of these products, it will be 0. Now concentration of this ester at any time t, this is 1 mole, and 1 mole of ester it decomposes into 1 mole of acid and 1 mole of alcohol. So its concentration will also be 0.01 mole and 0.01 mole, because 1 mole of ester on dissociation gives 1 mole of carboxylic acid and 1 mole of ethyl alcohol. So concentration of ethyl acetate left after time t is 0 mole, and suppose concentration of water after time t is 9.9 mole, again hypothetical value. Now we will discuss its rate. Now as we know, rate, it is directly proportional to concentration of reactant at time t, and concentration, there are two reactants in this reaction. First is ethyl acetate and another reactant is water. Take a constant, rate is equal to K is rate constant. This is CH3COOC2H5 and water. Now students, here the molecularity of reaction appears to be 2. Molecularity, what is the molecularity? Number of reactants participating in a chemical reaction. So here there are 2 reactants, so molecularity of this reaction is 2, but the order is not 2. Why the order of the reaction is not 2? Because this is rate constant and this water, its concentration is also constant during the course of reaction. The initial concentration of water is 10 mole, and after time t, when the reaction is over, after completion of a reaction, the concentration of water is 9.9 mole. Now there is no difference between 10.0 mole and 9.9 mole. It means concentration of water remain constant during the course of reaction. So this is constant, this is constant, this is rate constant, and concentration of water is also constant. So in mathematics, if there are 2 constant, take another constant in place of 2 constant. So this K and this water, this is constant, take another constant in place of these 2 constant, and the new constant is suppose K dash. So now rate will be in place of water and this K, I have taken a new constant K dash and this CH3COOC2H5. It means in rate law the rate is directly proportional to concentration of ethyl acetate. It means it depends upon concentration of ethyl acetate and it does not depend upon concentration of water. So now this reaction appears to be a first order reaction. So these reactions are known as pseudomolecular reactions, which are not truly first order but become reaction of first order when one of the reactant here, the reactant is water, is taken in large excess, so its concentration remain constant. That's why the order of the reaction now becomes 1. So it is pseudounimolecular reaction. Okay students.